cannot think of a better way to approach a new year than to kind of explode our mind and explode into the universe. And so I want to tell you a little bit about our guest author, Kelsey Johnson, who's joining us from Charlottesville area, lives there with her family and a few dogs and cats, I think. Teaches students both inside and outside the classroom using astronomy as a gateway science to nurture curiosity and support science literacy. As a child, Johnson spent countless nights outside under the stars, where she developed a love for the big picture questions about the nature of reality and the universe. Her curiosity about the cosmos has been the primary driver of her career as a professor at the University of Virginia in astronomy, founding director of the award-winning Dark Skies Bright Kids program, and past president of the American Astronomical Society. She has won numerous awards for her research, her teaching, and promotion of science literacy. Her TED Talk on the importance of dark skies has more than 2 million views. Pretty impressive. And her writing has appeared in nationwide publications, including the New York Times, Scientific American, and Washington Post. Her children's book, Constellation for Kids, is consistently in the top 10 children's astronomy books. Yeah, teaching kids. And she's here tonight to talk to us about her latest book, Into the Unknown, The Quest to Understand the Mysteries of the Universe. Let's give Kelsey a warm welcome. What struck you as a child in the night sky? What was it that really kind of sparked you're looking up there and that whole wonder of things?
Starting with the easy questions. First, just hi, everybody. So happy, I didn't know if we'd be talking to an empty room tonight, so this is delightful. And I've never had the joy of interacting with, I will say, students writ large who are drinking and possibly inebriated. So this is an extra bonus. And your questions, I'm hoping your questions will get really interesting the longer we're here. And that will be great. I'll have some fun stories to share with my spouse when I get home. Okay, so what sparked me when I was a kid? So the problem with this, so it's a great question. I love your question. This is not the fault of your question. The fault is with my upbringing. And that is that I grew up in the country and we had dark skies in our backyard. And there was never a moment where I had a spark. It was just baked into my existence as long as I can remember. And so I wish I could say, I had this one aha moment when I was outside and this great thing happened and my life has changed. I don't have a story like that. It's just always been part of my life.
And I think that's the point, is where you were, and you were always outside in the country. Is that right? Yeah. Not in the city?
No, we lived on, I'm sure where I grew up is now city. When I grew up, it was country. It was actually border. We had a little plot of land I grew up in Minnesota, when we can all talk about Minnesota tonight, but not on that topic. And the little plot of land we had was bordered by potato farms. And so I spent my childhood, every waking hour was outside playing in the dirt, climbing trees, building forts. Being outside at night was just a normal, and I think what you experience as a child becomes your normal. And so for me, that was my normal. And so I think the aha moment for me was when I realized that wasn't other people's normal. And that is actually kind of heartbreaking for me. That's the part that I think we were, if you're going to get me going, I don't have a soapbox right now. I feel like I'm going to need one. I'm like,
I'll get you a beer.
Like, we're going real deep and narrow real fast, but like one of the things I think that got me to actually invest myself in writing this book is a real tangible, it's more than concern, I would say fear I have for humanity right now, that most people, and I don't know what the number is, so don't make me come up with a number, but my impression is that the overwhelming majority of people right now, especially kids, are growing up, even those who grow up in farms these days, in most of the country, don't have access to a night sky, right? Just because of light pollution. And I really have I have lots of existential worries, but one of them is that what does it do to our humanity and our sense of who we are in the universe when most people growing up have never experienced the universe, and we can just forget that we're part of something much bigger and more grand than, this brewery is great, but there's a lot more to the universe than this. And I just really, really worry about how that's going to imprint in the long term on what we think of ourselves as humans.
Yeah. We said we were going to go down some different channels tonight. And the name of the book, remember, is Into the Unknown. So we are going to kind of do an unknown format here at Books and Brews and really open it up to questions and things like that. I'm going to open up with a few questions, but the topics that Kelsey covers in her book and the questions she asks, from the Big Bang, the dark hole, the dark matter, to the laws of the universe, they're expansive. And I think we could spend hours and hours and hours and many beers talking about this tonight. So,
well, I don't have a curfew, do you?
So, just to get an idea in the room, how many of you all are here tonight who've looked up at the sky and wondered? Okay, she dedicated the book to you.
That's true, I did.
Yes, you did. And how many are scientists? How many in the room consider themselves a scientist? Okay. What about astrophysicists? Do we have any astrophysicists in the room?
I don't, but my daughter's studying it at UVA.
All right.
I just wanted Kelsey to know what level of questions we're going to encounter tonight. But I think what's amazing about her book is she makes it accessible and opens the door for all of us. Anybody who's looked at the night sky, all of you who raised your hand and wondered about these questions. So thank you for doing that.
My pleasure. Thank you for reading it.
So in when did you first decide to go into astrophysics? Physics. Don't you like the way I said that? I'm going to be using a lot of interesting words because I had to use my dictionary throughout this book, and it's a great challenge.
Okay, now no one's going to read it.
No, but it's so humorous. It's so full of conversation, just like you are, and the way you're teaching. I told her I now know what hot black matter is.
It's a trick all of you can use at parties from now on. All right, so your question, how did I get into astrophysics?
Yeah, what made you want to go in this direction besides the night sky?
Okay, I have an internal dialogue going on in my head right now, and I'm trying to figure out, what do I want to say to these people I've never met before? And how candid do I be? And how many people am I going to offend?
They're having beer.
Okay. All right. So
Good
we're gonna get real as if we weren't right off the bat. So you already got the whole night I grew up with the night sky, right? So that seed had been planted, and I already, as a child, was exposed to the natural world. And I think when you're exposed to the natural world, I hope that for normal children and humans, it makes you curious and asking questions and those why questions. So that was already part of who I was. But the other piece that folds in, and this may not be what folks are expecting, but this is the truth, is that I grew up of my own accord. I grew up in a fairly, I would say, challenging situation. This was not in the book, so I didn't feel like I would put this in the book. I grew up with a single mom, and she was an alcoholic, and we were way below the poverty line, meaning we often didn't have running water or electricity or a working phone. You never knew when you came home whether you could call your friend or flush the toilet, honestly. And that's one of the reasons why I think the natural world became like my place of comfort. So I spent a lot of time just to escape being outside. And that's why I was outside a lot at night, because I needed to be away from my mom. But one of the things that led me, so I'm growing up in rural Minnesota, and I won't tell you when, but some many decades ago. And at that time, in the environment I grew up in, the only real recourse that I knew as a child that was available to me was religion. And, we had a tiny little bookshelf in our house. We didn't have very many books, which was heartbreaking, right? I'm just all about books now. But of this tiny little bookshelf we had that had maybe 24 books on it, I remember there was a Spanish-English dictionary. I don't know why we had a Spanish-English dictionary, but we did. And I remember trying to read it thinking I could learn Spanish. It turns out that's not how language acquisition works. But we also had 3 different versions of the Bible. And so I spent a lot of time as a child reading these Bibles like over and over and over again. And of my own accord became extremely church going. But when I was old enough to drive, I would drive myself. I taught Sunday school. I went on retreats. I did meditations. I did everything that I was told in my religion. I don't want to cast any, religions are all very different, but in the religion that I subscribed myself to, I did all of the things that a good girl was supposed to do. And at some point I realized that the questions, I remember thinking early as a child that all of my questions about the universe would be answered if I read the Bible enough. And it's somehow in the Bible, these things were encoded. And I kept reading the Bible over and over and over again and realizing that my questions were not being answered. And then one day I had a middle school teacher who, teachers, God bless teachers. How many of you are teachers? Is anyone a teacher? Like, thank God for you and the power you have on students' lives. Like, for real. I had a teacher that took my class to the local university library. I had no idea that much was known about the world. And I checked out books on like time travel and black holes. And my mind was blown. And I remember thinking, oh, there's another way to knowledge. And then I think I never really turned back. Sorry, that was not where you thought we were going to go.
No, I love that. That's where we're going tonight, into the unknown. And you have a quote that I have to read that I love.
Just one?
That kind of addresses, there's many. But this one, any belief system too fragile to permit people to reach their own conclusions is inherently flawed and unstable.
Yeah.
I think that says a lot about when all of those thoughts and collide into trying to figure out why we're here, these large questions that you're putting out there. So you mentioned that you started the book 3 times over 15 years. And I'm sure that with all that you're doing, the papers, the writing, the research, what was it that kept bringing you back to write this book for all of us?
These poor people who came tonight and wanted to talk about space are getting like my life story.
We're going to go into dark,
So this is morbid. As we laugh about death. I don't know if any of you are of a particular age where you start thinking about what you want to leave behind. I realize, I'm not quite at the age where I'm acutely worried about that, but it is, life happens, things happen. And at some point, I kind of had this book in me for a long time. And like this real, I don't know if any of you feel that way about projects you have or projects you want to do. It's like in there and you've got to get it out, but you just can't quite seem to find the time or the space. And you want to do it, but it keeps getting put off. This book was one of those things for me. And at some point, I don't know, some moment of existential something, I really started ruminating on, if I do nothing else in my career, okay, let me phrase it this way. What do you want on your obituary? Right? Do you want it to say that you made X number of dollars and you had this job and you got 5 promotions? I don't know. To me, that rings kind of hollow. If that's what you want on your obituary, you be you. I'm not passing judgment, but for me, that just rang hollow. And I'm like, and as an astronomy professor, the metrics we, use in our profession are how many papers did you publish and how many citations did you get and how much grant money did you bring in? And okay, those things it's not that they don't have value, but I just found myself thinking, really, is what I want in my obituary how many papers I published and how many citations I got? Like, no, that's not what I feel like I have to give the world. Like, how many of you are going to go pick up an astrophysics journal and it's going to change your life? I just feel like that's not, I don't know. I felt like there was something in me that had to come out, and I felt literally impelled to do it. So you got this like brain dump vomit of the book.
It's the most wonderful thing. I mean, anyone who is impelled to do that and to bring it to someone who maybe doesn't have a science background, who is a reader, but wants to understand these same questions. You've done that for us in this. So my next question is about, and then we're going to be thinking about, because these are the topics that she covers. If you all haven't read the book, you'll need to get a copy tonight.
That would make Mary Katharine really happy.
Yes. But the questions, I just want to say, what is knowledge? What caused the Big Bang? Does extraterrestrial life exist? These are chapters. What are dark matter and dark energy? What happens inside a black hole? What is the nature of time? Are there hidden dimensions? What determines the laws of nature? Is the universe fine-tuned? Such a question. What is our place in the universe at the end? So this is the level of chapters you're looking at in this book. And my question to you is, your book has been out since October 2024. What have readers most asked about? What have they been most drawn to?
I think what I have heard most from readers is, this is interesting. So one of the things, you haven't mentioned this overtly, I try, thank you for that. I try really hard to do in the book is stay really humble and maintain some intellectual integrity about what we know and what we don't know. And I think it's really easy for all of us, I mean, not just scientists, but all of us to overinflate what we think we know. I don't know whether it's like hubris or we don't like to be wrong, or I don't know where that comes from psychologically, but I tried really hard to leave space for things we don't know and we don't understand. And some of the things that can occupy that space, which include a higher power. And I try to be fairly overt about that in the book, although I do try to keep my own religious beliefs kind of tucked away, because I don't want those to become the topic of conversation. I do want to be honest about what our limits of knowledge are, and why those are our limits of knowledge. And so back to your question, finally, I think a lot of what I have heard from readers has to do with, this sounds like super self-aggrandizing, but a lot of people have told me they found it refreshing that I was willing to be open and honest about the limits of knowledge and what they are scientifically, and that I wasn't trying to just shove scientific dogma down people's throats. And so that's a lot of the feedback I've gotten. I've also gotten a lot of crazy emails, but that's okay.
You definitely leave it open to all of us who don't understand maybe the full page equation, but
only like 2 people in the world do. You're fine.
I look at it and I just went, that's nice. But then, you can really kind of understand that there's so much that we don't know. And that's what I think is beautiful about what you do. So I'm gonna start pitching it out there, because I told you I would, to you all, to talk about the topics and to really structure this conversation beyond what I've said.
Do you have an example of scientific dogma?
An example of scientific dogma.
Scientific dogma. We could take the Big Bang. This is like the grandmother of them all. And I think that's where most scientists start to get a little bit itchy, because we don't know what caused the Big Bang. And but that's where many, not all, scientists, I think, are like, well, it was a whatever they say it was, without leaving room open for that. Maybe that's not a great example. Yeah. Maybe the bottom line for me is all of us need to exercise humility. in what we know. And I know this will be shocking to people, that scientists are not always the best at exercising humility. I didn't really answer your question, but I'll have to think about it. I mean, do you have an example of scientific dogma?
No, but just there's scientific truth.
Yes.
We know.
Yes. Yeah. So scientific truths that we know. So this is really interesting. I know you're really looking forward to this. There's a whole chapter on epistemology.
I was gonna say the first chapter goes right to that.
Because one of the things I spend a lot of time thinking about as a scientist is, how do we know what we know? And why do we think we know it? And one of the things I challenge my students to do in class, there's a class I teach, and always like the first day of class, what I do is I without really any context, I ask my students to write down 3 things that they know. And for most of them, this is pretty trivial. They're like, my name is John. I'm wearing jeans. I live in Dillard. And I have a lot of fun going around the room, challenging them on what it means to know these things. So let's say, John, I'm picking on John. I don't know why John came to mind. I don't know how many Johns we have in the audience, and I hope you don't feel picked on, but I'll go to John and I'll say, okay, well, tell me, why do you know your name is John? And John will say something like, well, they'll have to pause and think about it. Well, my parents told me, and it's on my birth certificate. And my response to that, as a parent of 3, is, hey, I'm pretty sure that every parent in the history of humanity has lied to their children. That's just the reality of the situation. And so can you be 100% sure that your parents did not lie to you about your name? Well, maybe 99.99999% sure, but not 100%, right? You have to leave a tiny sliver open that maybe your parents lied to you. It's possible. Well, it's on my birth certificate. Are you going to argue to me that there are no birth certificates that are forged? Right? And so you can always there's a difference between, I think, and this is what I try to argue in the book, there's knowing things with a capital K. Like, you absolutely, to the bedrock, know that to be true. And then there's knowing things colloquially, like with a lowercase k, that we think we know because all empirical evidence to date really suggests this is true. Like, your name is John. I believe you that at the 99.999 whatever percent level, your name is John, but it's not 100%. And the closest I would argue we come to really knowing things, and there'll always be a smarty pants student that, they get my game, right? I'm going around the room poking holes in everything they think they know, and they get really frustrated, and some of them get mad. That's fine. I have tenure. I don't really care. And eventually some smarty pants students will say, like, well, I know 1 + 1 = 2. Someone stumbles on math. Math is as close as we can come, I would argue, to actually knowing things with a capital K. But here's this crazy thing. So if you wanted hopefully you can leave tonight with some fun facts to share at a party. Instead of like, Happy New Year, how's it going? You can say, I learned this cool thing. Proving 1 + 1 = 2. I don't know if any of you have ever tried to do that. You're like, how would you prove 1 + 1 = 2? It just is, right? Am I wrong? Maybe you all are like math geniuses. It turns out to actually be really hard. And there were 2 mathematicians, Whitehead and Russell, who wrote a book a long time ago called Principia Mathematica, in which they tried to set out to prove 1 + 1 = 2. It took them 300 pages, and it was based on assumptions that themselves are not provable. So I'm just going to let that sit.
It might be time for another beer. Yes. Over here.
My name is Joe Rudman, and I also faithfully go to church. And I have a challenging statement about dark energy. Dark energy, for the people around here, others, dark energy is the term we give to the slight acceleration of the expansion of the universe. It's both paradoxically counterintuitive and obvious that dark energy is just ordinary gravity. When you think about 2 objects falling into a black hole, one in front of the other, the one in front has a stronger force, so it accelerates away from the one behind it. If 2 objects are falling side by side, the path that light takes between them gets more and more arced, and light takes the shortest distance between 2 points. They're also getting farther apart. So the larger gravitational field drives apart objects in its gravitational field. We can also see it another way. Dark energy is this mysterious long-range field which has a negative energy density. And contrary to standard GR, obviously gravity has a negative energy density. When you have electric charges, putting electric charges on a sphere, those charges repel each other. You got to do work to get them on the sphere, and that puts energy in the electric field. With gravity, mass plays the role of charge, but instead of the charges repelling each other, they attract. So if you assemble a sphere of matter, you get energy out. That's the negative energy density.
All right.
Okay. We just got a lesson from Joe. If I might offer a few humble comments. Yeah. I love, Joe, that you brought up dark energy. This is one of the most vexing things in astrophysics right now. You all might know the universe is expanding. If you don't, that's another fun fact you can tuck away. Not only is the universe expanding, it turns out the expansion of the universe is accelerating. And we learned this a couple decades ago. When it hit the press, all of us in the field were skeptical. We're like, no, wait, that's not what's supposed to happen. There are some hypotheses for dark energy on the table. We have not been able to robustly test any of them. All of them would be revisions to physics as we understand it. So I'm just going to maybe, I don't know, you all need some notebooks to take notes on. So another fun fact, though, that Joe brought up about gravity. So it's really interesting. Most people always think of gravity as being attractive, right? Because that's your normal experience, like the earth is holding you down, which is probably good because you're all been drinking. But here's the thing with gravity. When we, and I know you all are going to go home and do this, when you start working with general relativity, there's this I'm sorry, there are terms here and I just have to use them because I don't have other words. And if you don't understand what the term means, it doesn't really matter, but I don't have another noun to put it in its place. So it's like Mad Libs. Just put some other noun in there. You can say like dog or pint of beer. So the word is matrix. And in general relativity, there's a matrix or a dog or a pint of beer. And in this matrix, there are different terms. And one of those terms, and the behavior, the properties of this matrix determine what space-time does, and that's what determines gravity. Okay. But in this matrix, there is a term for pressure. And we know what pressure is, right? You like blow up a balloon and there's pressure. You go up in an airplane and the pressure goes down and your ears pop. Like people have an experience with pressure. It's possible to have negative pressure. And if you have negative pressure, that's actually negative gravity. And then gravity actually becomes repulsive. So that's your fun fact.
Yes, we need to process that. I have a question back here. Is the cosmos infinite, and how do you rationalize that? Does it go on forever?
We don't know. I mean, do you want me to say more?
Yes.
All we can say, the only things we can say about the cosmos, at least given our abilities today and our technologies today, and maybe there's some way around this that someone being born today will figure out, but we can only learn things about the cosmos out to distances as far as light has had time to travel to us. And for us today, that's about 13. We've had, about 13 billion years of light being able to travel to us. And so as far as we can tell, within what we think of as our horizon, as far away as we can see, there's no end to the universe. But that doesn't mean like astronomers love balloons. And if any of you had an astronomy class, like ever, were there balloons used? Okay, I'm really sorry. Astronomers really love, I don't know, it's this thing. We use balloons for everything. Okay, so I'm going to offer you an analogy, but it's a little bit abstract. So you might have to bend your brain a little bit here. Just now, we weren't doing any brain bending before. Okay. Imagine that. Okay. We live in 3 dimensions of space, right? We're all on board with that. Imagine that for whatever reason, we don't perceive the 3rd dimension and we live on a 2-dimensional surface. And we're going to think about that 2-dimensional surface that we live on as the surface of the balloon. We have to ignore that 3rd dimension because otherwise I'm going to ask you to envision too many dimensions, and most humans I know can't do that, including me. So if we live on the surface of a balloon and that balloon is the universe, the part of the universe that we can see could be 90% of the balloon, or it could be this tiny little patch. And we don't know. Even if the universe is a balloon, right? I mean, this is where the balloon analogy breaks down. For the record, we don't know it's a balloon. And if it were a balloon, that would be finite. It would close back in on itself. We don't know that to be true either. And so one of the big outstanding questions in astrophysics that did not make it into one of my chapters is, what is the shape of the universe? Is it infinite? And the real answer is we don't know. And we don't even see a path to knowing anytime soon. And so your question stands, and you can keep asking it for as long as you want. And if anyone gives you an answer, they're lying.
We got a question back here. The concept of the multiverse is what he's struggling with, and he will buy your book if you can give a good description.
Okay, well, the pressure is on. Yes, I have a whole chapter in the book devoted to other dimensions in which I talk about multiverses. For the record, it's not the multiverse. There are many different types of possible multiverses. Like there's a whole taxonomy of possible other universes. And this I love, right? This is where it starts to sound like science fiction, but it's actually really not. And there are, to be clear, we have no actual evidence for other universes. Wait, what? But that being said, there are things that live in our best theories of the universe right now that suggest there could be, or even ought to be, other universes. And then the question as a scientist becomes, well, how would you test it? And this gets really hard because if we only have access through the laws of nature and the forces of nature to our dimensionality in our universe, how would you possibly how would you get outside of your universe to test for the existence of other universes? And so, let's see, back to your question. Can I explain the multiverse? I don't know if you're going to buy the book now. Okay, bring it. Yeah.
Does this multiverse live in parallel with us? Or is it way, way out there at the shape of the universe we don't know still?
Yeah, we also don't know. And there are hypotheses on the table for all of those scenarios. So, for example, there are scenarios in which there are other universes that exist outside of the dimensionality we're familiar with, right? We have 3 dimensions of time and 1 dimension of space. There's no reason to think those are the only dimensions that exist. It's just those are the only we're able to interact with. And it could be that in a hyperdimension, like one more dimension that we can't perceive, for whatever reason we can't perceive it, like, a millimeter away from us could be this whole other construct of a universe. I don't know if millimeter even makes sense as a unit of measurement when we're talking about hyperspace, but we're going to go with it. I'm sure that aliens use metric. And, but
They gotta use metric.
we don't know.
Back here in the very back with the hand up really high. The question is, have you heard of Walter Russell's philosophy? And how unusual is it that the moon eclipses the earth perfectly?
So I will confess that I can't bring to mind what Russell's philosophy is. So you might have to school me on that later, and I'm there for it because I love learning, and it sounds like this is something interesting to learn about. The moon eclipsing the sun. Okay, this is weird. This is one of those things that's like in front of you, but many people never think of. And we have another great, well, it's not going to cross North America. Did any of you see either of the last 2 eclipses we had? Like totality? Okay, I see a lot of people I meet are like, well, I saw it at 90%. I'm like, 90% is not totality. Like if you have, like, it's just, yeah, you've got to see totality. You can't even express how cool totality is. There's another eclipse coming. Well, there are 2 eclipse seasons a year. There's another eclipse season coming in August, and I'm going, I'll be the faculty host on a UVA trip to Spain. We'll be on a cruise ship watching the eclipse. So if you're interested, I know I live a terrible life. Okay, so here's the thing. For the moon to eclipse the sun, and just for the record, right now I need an extra hand. Okay. It's all right. It's all right. I'll make do because I need a third hand on my own body to like move things around. And even extraterrestrial life may not have that. I mean, well, okay. So here's the thing, right? So envision the Earth, the moon, and the sun. And this is, you can see why I need to hold like 3 things, but I'm confident that you all can envision the Earth, the moon, and the sun. in a line and in that order, right? And it's when the moon is between the earth and the sun, exactly between the earth and the sun, that we have a total solar eclipse, right? Okay. How crazy is it that the moon is exactly the same size on the sky as the sun, right? I think that's the origin of the question, which if you stop and think about it, you're like, wait, that seems like a setup job. And it kind of does. Okay, but here's where it gets, maybe you can feel extra special leaving tonight. So over time, the moon has been getting farther away from the earth. It's due to something called tidal drag, and we don't need to go into the physics of that. Related to it is that the Earth's rotation is slowing down, which means days are getting longer. So you can be grateful for that. It's like a millisecond every million years, but days are, I totally made that up. I don't know the number off the top of my head, so don't like quote that. This is not a note I want you to write down, and there won't be a test. Earth's days are getting longer, and the moon is slowly moving farther away. What that means is that some time ago, before all of us were born, the moon was closer to the Earth and actually bigger on the sky. So it used to be bigger than the disk of the sun on the sky, and so eclipses would have been more common. Now, sometime after we are here, the moon will be farther away from the Earth, and we will no longer ever have total solar eclipses. And so we're actually living at a very special time right now. I mean, the time is many, many, many thousands of years. But in the history of the Earth, we're actually living at a pretty special time when when the moon on the sky is the same size as the sun. Now, is it a setup job? I don't know.
Talk about dark matter.
So talk about dark matter, something we observe from afar, and that the model is maybe not working out what we expected it to be.
That was a dangerously open-ended question to ask me. Talk about dark matter. Okay, so let me start by giving just a little bit of a primer, because I want to make sure that we don't launch on some conversation and no one knows what we're talking about. Okay, so here's the situation. You're all familiar with gravity, and gravity has a big, important role in the universe. And when we look at how bodies orbit, like we could think about the Earth orbiting the sun, and the orbit of the Earth around the sun has to do with the sun's gravity. And if the sun had more or less gravity, it would change Earth's orbit. And we're going to skim over all the physics here. But what I want you to internalize is that the gravity of an object about which things orbit determines the orbit of the objects that orbit. That was probably the most convoluted way I could possibly say it. Now, when we look out in the universe, so for example, when we look at our galaxy, we look at other galaxies, and we look at how things orbit, what we find is that there's more gravity causing their orbits than we can account for. And the bigger the objects we look at, so if we look at a galaxy, we see some of it. If we look at a galaxy cluster, we see more of it. If we look at a supermassive galaxy cluster, we see even more of it. And so the larger scales we look at, the more of it we see. Now, so there's some source of gravity that we can't see, which is why we call it dark. So dark in astronomer speak is code for we don't know what it is and we can't see it. So we call this dark matter. And it's really fun. I don't know if any of you are thinking this, and if you are, I'm just going to embarrass you straight up, but you don't have to confess. When I talk about dark matter, as one does on an airplane or in a taxi, often what I hear is, well, have astronomers thought about black holes? Like, no. You're right. Like thousands of astronomers have been thinking about this for like 50 years, and none of us thought about black holes. I don't mean to get too snarky on you, but good for you for thinking of possible solutions. I think often people say black holes because they're thinking, okay, what are things we can't see that have mass? And I love that people are making that connection. Like, okay, I know of a thing we can't see that has mass. Black holes. Must be black holes. So no, it's not black holes. We've also ruled out pretty much everything we can think of that we can't see. So for example, really like planets, different kinds of subatomic particles, all kinds of things that for whatever reason, they don't interact with light. So fun factoid number, I don't know what we're on, 5 or something, 4. Things that have mass don't have to interact with light. That's a property of some kinds of particles. And, we think of things as having mass as having to interact with, they either absorb light, they reflect light, they emit light. Turns out that's not necessarily true. And there are particles in the universe that don't interact with light. And so we have been, over the last couple decades, like testing more and more and more ever increasingly weird hypotheses about what dark matter could be. We are, depends on who you talk to. If you talk to physicists who are testing subatomic particles in the Large Hadron Collider, they're like, oh, there's plenty of room for subatomic particles. Freaking find one. It remains an open question. And I would argue, and there are physicists who would argue back with me, and that's fine, because what's more fun than arguing with a physicist, right? I would argue that we're getting to the point, we're not quite there yet, but we're getting to the point where if we don't find these handful of remaining particles that we think could be dark matter, we've really got to think outside the box, even more than we have been. And there are some outside the box theories that I think most people don't want to think about because they sound, as many outside the box things do, they sound crazy. I am, for the record, I'm a fan of letting ourselves think about some crazy things, right? Because sometimes crazy things turn out to be true. And if we don't let ourselves even think about them, we're just cutting off a whole line of inquiry. So yeah, bring on the crazy thing, have skepticism, think about how you're going to test it, but let yourself think about the crazy thing. And so one of the crazy things that is, on the edge of the table, but being shunned aside by all the normal things on the table, is other universes. So one fun factoid number 6 is with gravity, the belief in physics, though I say belief with intention because this has not been proven to be true. We believe that gravity is carried by a particle called a graviton. We have not observed gravitons, but we think we know what their properties are. And one of the properties of gravitons, we think, is that they would not be tethered to our 3 dimensions of space, meaning gravity could leak outside of our universe. If that's true, and I'm getting way in like crazy skeptical land here, if that is true, emphasis on the if, and gravity can leak outside of our universe, and there are other universes, their gravity could leak into ours. And so there are all kinds of outlandish theories like that could be true. So is that enough talking about dark matter? All right, there's a whole chapter.
There is a chapter. And was that the chapter you said that by the time this comes out, there will be revisions to this?
Yeah, that's a chapter I think I'm most likely to have to revise.
So there will be updates, right? Did you like the movie Interstellar? And if so, why or why not?
I feel like I'm writing a college essay now. Can I do it in 5 paragraphs with a strong thesis statement?
Go straight to the strong thesis.
I loved the movie Interstellar. I really, truly did. I know scientists who, scientists tend to be kind of touchy about science fiction movies and where they fall. I loved it for a number of reasons. We'll put the plot aside and the actors aside. I did love the soundtrack, though. The soundtrack was really good. One of the things I really have to applaud the folks who made Interstellar was that they actually consulted a physicist on the movie. They consulted a world-renowned expert, probably one of the world's biggest experts on black holes. His name is Kip Thorne. And they consulted him on the movie. And so much of the movie is based on our actual understanding of black holes and how time behaves and gravity. And so there's real physics in there. And yes, there are some things that are not known physically, like otherwise the movie wouldn't work. I'm willing to hold and suspend my disbelief for those parts. But I did love the movie, and I loved it so much that I actually assign it usually for extra credit in my classes because I want the students. I think it's a great movie. All right, hold on, pause. How many of you have seen Interstellar? All right, how many of you have not seen Interstellar? Good Lord. What is wrong with you people? Now you have homework. You did it. You need to go watch this movie. But one of the reasons I assign it is that when we talk about general relativity in class and how gravity makes time behave in a way that is counterintuitive for us humans, Interstellar does a really good job of helping make it more tangible, insofar as it can. And anyway, I loved the movie. It always makes me cry. Sorry, I don't mean to give spoilers. There are some sad parts, but it has a really good soundtrack.
Okay, the music makes it better. Yes, behind you. Oh, that's a great question. How do you take this is a general question on writing. How do you take something like astrophysics and bring it to the general public in a way that's accessible?
That's a great question. I don't know how many people in the room that will be applicable for, but I'm happy to answer it. And also, thank you for having a good time. Keep having a good time. So I think my secret weapon here was just teaching, right? I've been teaching undergraduates astrophysics for a long time. And I think through that process, I don't want to be delusional about things, but I believe I have gotten a better understanding of where people hit a wall, where there are challenges, what's hard to understand, what's not hard to understand, where you need an analogy. And for me, I hope you'll get this from this conversation now. I try to be pretty informal. My sense, both in teaching and with the book, is that when people open a book and it's like formal and I don't know, I changed my voice. I'm like, let's be very serious. I find it to be not inviting. And so for me, a lot of it is, yeah, there are some concepts in this book that are hard to get your head around, and that's okay. But let's be inviting and welcoming and I try to acknowledge in the book, there are a couple places where I say, this next part might be a little bit tricky, and that's okay. And if you need to skip forward and come back to it later, that's fine too. But I want you to hold on to that curiosity and know that you can come back to it. I guess another secret, this is not like a trade secret. It's like, I have good proofreaders, right? I send it to people I trust who are non-experts to really ask them, where did you run into trouble? What was clear? What wasn't clear? Because there's no substitute for that. Because otherwise, if you're just living in your own head, you can be infinitely delusional. I don't know if that answers maybe that applies to some of you.
I will attest to that as a reader through this, December holidays and all of the other times. She was so encouraging to say, it's okay. You're not going to understand maybe the next 2 pages, but keep going, which I appreciated. The question is about time and whether it's truly linear or whether we can actually go back and deal with trauma in the past and other things that we need to deal with.
Time is such a great topic. Thank you for bringing this up. And you're a teacher, right? I love that. Okay. I would argue time is, and I think I say this in the book, is one of the things in the universe that we have the most exposure to, right? We're just embedded in the flow of time, whatever that is, and the least understanding of. We really don't understand what time is because we can't get outside of it, right, to observe it. It's kind of like our own universe. We can't get outside of it to observe it. But we do, time, I would say 100 years ago was entirely in the realm of philosophy. But modern physics actually has some things to say about it. Now, the things it has to say are sometimes contradictory. So we have to walk that line. But here's the thing about time. One of the things that I realize we're talking a lot about general relativity here, so some of you may need to take more notes. One of the things that general relativity suggests, and I'm using the word suggest with intention, is that in a very real sense, the past still exists and the present exists, we're in it, and the future already exists. Now, can we prove that? No, not yet. There are reasons to think that that is true, but then that flips the question to asking, why are we experiencing this moment of time right now? Or is there a version of us experiencing every possible moment of time and we're just not aware of them? And so it spins off a whole other set of questions, but there are real reasons to think that it could be the past still exists and the future already exists. But then that leads to a whole other can of worms.
Right.
Yeah.
Open up like date and
Free will.
Yeah, exactly. So 100%, this opens up concepts of free will and fate. And so this is where quantum mechanics enters the stage. So we haven't talked about quantum mechanics yet. So one of the things in quantum, all right, I'm having a conversation in my head right now in real time. One possible interpretation of quantum mechanics is that, and I'm skipping over the physics here because otherwise we're never leaving. I don't have a curfew, but I know you all are underage, and so I have to be mindful of that. In quantum mechanics, one of the interpretations, this is not necessarily a popular interpretation, but I'm of the mind that popularity is not a good arbiter of truth. One of the interpretations of quantum mechanics is that every time something happens, which in physics we call a wave function collapse, but we could just say something happens. Every time something happens and there's a wave function collapse, different universes split off. And if that's true, those different universes have different outcomes. And if those universes have different outcomes, there's a universe in which you decided not to ask a question, and there's a universe in which you did decide to ask a question, and they have different outcomes. And so if is with intention, if that is true, then suddenly there's something opening up about different possible futures. And does the opening up of different possible futures now allow for something like free will? But then why do we find ourselves on the path that we are to begin with? So it's all very mixed up. But I love time.
Convergence of many areas, philosophy, theology. Yes.
Could I tell you?
Einstein's spooky action at a distance, and are you studying it?
I can tell you. Was that your question? Okay. Here's how this works. We're going deep into physics here. So in physics, there are things that are called entangled. And one way to think of this is let's pretend we have an imaginary machine. And it has like all kinds of knobs and dials, and it's like that awful like military physics gray color. Do you know what I'm talking about? That like all physics equipment seems to be. And you can hear like vacuum chamber. Have any of you ever walked down the hallway in a physics department? It's usually grim, I'm just going to say. Okay, so we have this physics machine. And in this machine, it's going to have an interaction, and it's going to create a pair of particles. It's going to create a positron and an electron. A positron is like an anti-electron. It's like an opposite electron. And because of the way these particles were created, they have to be opposite. So just bear with me here. This is one of those places where I'm like, hold on. And by opposite, I mean one of them has to, I'm going to skip over terminology here. One of them has to be up and one of them has to be down. We don't know which one is up and which one is down, but one of them has to be up and one of them has to be down. So everything so far is fine and physics is fine. But quantum mechanics enters the room and tells us that when we look at these two particles, the positron and the electron, one is up and one is down, except we don't know which. And it's not just that we don't know which, it's that they don't know which. Both of them are simultaneously up and both of them are simultaneously down, and both of them are neither and both of them are both. And so let's say we take these two particles, they're having this identity crisis and they don't know whether they're up or they're down, and they're in this machine, and we send them off in opposite directions. So we send one particle off that way and we send one particle off that way. All right? They're both up, they're both down. Neither are up, neither are down. Now, we have a machine over there, and one of the particles goes over there, and we measure the particle and we find that it's up. That means that particle has to be down. Okay? So far, so good, right? Except that particle didn't know it was down until we measured this particle and forced it to decide. Mm-hmm. So we measured that particle, we forced it to decide whether it was up or down. It decided it was up. And so instantaneously, faster than light, instantaneously, that particle had to know it was down. That's spooky action at a distance.
Are you studying it?
Oh, are we studying it? It's hard. So people are definitely studying quantum mechanics. There are I'm using the word hypothesis a lot tonight because a lot of these things, that's why they're unknown, right? We don't know. We have hypotheses, but they're unknown. One of the hypotheses on the table for what explains space I don't know if you've ever thought about what is space. Actually, what is this 3 dimensions we live in? One of the hypotheses on the table for what space is actually a network of micro wormholes. Not going to say necessarily that I buy into that or not, because we can't test it. But if space is a network of micro wormholes, that could help explain spooky action at a distance. And so that's just one of the things we're, playing around with. And let's hope that like corporate America never gets their hand on that, because I don't know what they would do.
We probably have time for one more question right here.
Okay, so I'll repeat the question. So the James Webb Space Telescope hasn't had any new discoveries that have really challenged our understanding of the universe. Is that fair? Yeah. So hopefully y'all are paying attention to the Webb telescope. It's really phenomenal. I was on the advisory committee for it before, as they were building it before it launched. So I got to see it in the clean rooms, and that's the kind of experiment where it's literally billions of dollars and one wrong thing will make it fail. So that's a little bit scary. So the thing with science, so the short answer is yes. Webb has seen things that are causing us to revise some of our hypotheses. So for example, it's finding things in the very early universe, meaning many, many, many billions of light years away, that are more massive than we thought they should be at that point. I realize that sounds like, how is that going to change our understanding of physics? Well, it's changing our understanding of dark matter and dark energy and how things are seeded. And so it's just a simple thing like finding things are more massive than they ought to have been at a time, like puts a wrinkle in some of the ways we think about things and is causing us to challenge them. But a lot of the way, this is not the question you asked, but it's the question I'm going to answer. I just want to be honest about that. Like, I heard your question and I respect it. But a lot of the ways science progresses in general yes, sometimes there are big paradigm shifting discoveries like dark energy, like that, like threw physics on its head. That's like a once in decades kind of situation. The way science normally proceeds is like little experiment by little experiment, and a little tweak here and a little tweak there. And these tweaks sort of build up. And as the tweaks build up, eventually they might get heavy enough that they actually flip something, right? But mostly it's a lot of slow, meticulous learning about things and trying to put in individual puzzle pieces. And so a lot of what science does in general, not just Webb, but a lot of science does in general is sort of, finding one puzzle piece at a time and eventually realizing like the puzzle doesn't fit. But we have to go through this really painstaking work that isn't so flashy. It's not necessarily newsworthy, but it's how science happens.
You can see that we could cover many, many things in tonight's book discussion, and so grateful for you being here tonight. Is there anything you want to leave us with as far as a question? You left us with homework. In the book, at the last page, she says, I'm going to give you homework. And I'm hoping my homework has been done.
I am a fan of homework. I should think about this. Is one of those things where you're going to talk to people who are drinking and you should really think about a take-home message, and I didn't. To be fair, it was the first day of class at UVA yesterday, so there are other things happening. I think my take-home message, because this is always what is most resonant for me, is insofar as you are able, stay curious and try to enable the curiosity of people around you, especially children. I have all these existential worries about the fate of humanity right now, but one of them is that people are losing their curiosity. And I think that's to our peril if we don't really think about things. And so again, to the teachers out there, like, bless you, right? To those of you who might be parents or grandparents, like, please don't ever tell a child, like, that's the way, when they ask why something, don't be like, because that's the way it is, right? Please embrace it and be like, well, let's go find out together. And also there's something about curiosity that I think is just so fundamentally important, and I'm so worried about us losing.
Thank you. I think that you've brought us a whole bunch of things to be thinking about and be curious about, and homework as well. So thank you for being here tonight. Let's give her a hand. Books are available over here.